The MiG-27 Flogger is a variable geometry ground attack fighter developed by the Soviet Union during the Cold War to deliver high-speed, low-altitude strike capability against heavily defended battlefield targets. Conceived at a time when NATO and Warsaw Pact planners expected large-scale conventional conflict in Europe, the MiG-27 was designed to penetrate enemy airspace, survive intense air defenses, and destroy armored formations, logistics hubs, and tactical infrastructure. While not a multi-role air-superiority fighter, its role was precise and demanding. The MiG-27 matters in modern air warfare history because it represents a distinctly Soviet approach to battlefield air attack, prioritizing speed, ruggedness, and firepower over versatility or stealth. 2. Origin and development history. The MiG-27 originated in the Soviet Union and was developed by the Mikoyan Design Bureau. The program began in the late 1960s as a specialized strike derivative of the MiG-23 Flogger fighter. The first MiG-27 prototype flew in 1970, and the aircraft entered service in the mid-1970s. It was developed to replace earlier subsonic attack aircraft such as the MiG-17 and Su-7 in the tactical strike role. The MiG-27 competed internally with other Soviet attack concepts, but was ultimately adopted because it leveraged the existing MiG-23 airframe while offering improved survivability and payload for ground attack missions. 3. Design philosophy and airframe. The MiG-27's design philosophy emphasized low-level penetration, high speed, and heavy ordnance delivery under hostile conditions. Its airframe is based on the MiG-23, but features significant modifications. The variable sweep wing allows the aircraft to optimize performance across different flight regimes. Swept back for high-speed dash and forward for takeoff, landing, and low-speed handling. The fuselage is constructed primarily from aluminum alloys with steel and titanium in high-stress areas. Unlike later stealth aircraft, no radar-absorbing coatings were applied. Visually, the MiG-27 is distinguished by its sharply sloped nose, redesigned to improve downward visibility for attack missions and to house targeting and ranging systems rather than an interceptor radar. For engine and propulsion system, the MiG-27 is powered by a single Tumansky R-29 turbojet engine, manufactured in the Soviet Union. The engine produces approximately 12,500 kilograms of thrust with afterburner, and around 8,800 kilograms dry, depending on variant and source. This powerful engine enabled high acceleration and sustained supersonic flight at altitude. The thrust-to-weight ratio supported rapid ingress and egress from target areas, a critical requirement for survivability during low-level strike missions. However, the turbojet design was fuel-hungry and generated a strong infrared signature. 5. Speed and flight performance. The MiG-27 has a maximum speed of approximately Mach 1.7, or around 1,850 kilometers per hour at altitude. At low altitude, maximum speed is significantly reduced due to aerodynamic drag and structural limits. Typical cruise speed is subsonic during strike missions. The service ceiling is approximately 17,500 meters, or 57,400 feet. The aircraft's rate of climb exceeds 200 meters per second under optimal conditions. Maneuverability was adequate but not exceptional, as the aircraft was optimized for stability and weapons delivery rather than sustained air combat. 6. Range. Endurance and fuel. Internal fuel capacity is approximately 4,700 kilograms. The combat radius varies by mission profile, but is generally estimated at around 780 kilometers for low-level strike. Missions. Ferry range, using external fuel tanks, can exceed 2,000 kilometers. The MiG-27 can carry external fuel tanks on underwing pylons. but does not feature an aerial refueling capability in most variants, limiting endurance compared to later generation strike aircraft. 7. Fuel consumption and operating cost. Publicly available estimates indicate that the MiG-27's turbojet engine consumes fuel at a high rate, particularly during low altitude, high-thrust flight. Exact fuel burn figures vary, but the aircraft's endurance was a known operational limitation. Operating costs were lower than those of modern Western strike fighters, but high by Soviet standards, due to engine wear, maintenance demands, and the complexity of the variable geometry wing mechanism. Logistics support required significant ground infrastructure and skilled maintenance crews. 8. Avionics and sensor systems. Unlike interceptor variants of the MiG-23, the MiG-27 does not carry a full air intercept radar. Instead, it is equipped with a laser rangefinder and targeting system, along with optical and navigation aids optimized for ground attack. Avionics varied by variant, with later versions, such as the MiG-27M and MiG-27K, receiving improved navigation and attack systems. Sensor fusion was minimal by modern standards, and pilot workload during low-level attack missions remained high. 9. Weapons and payload. The MiG-27 is armed primarily for air-to-ground warfare. It carries a powerful internal cannon, typically the 6-barrel 30mm GSH-6-30, capable of firing at a very high rate. External hardpoints allow a maximum payload of approximately 4,000 kilograms, including unguided bombs, rockets, cluster munitions, and some guided weapons in later variants. Limited air-to-air capability is provided through short-range infrared-guided missiles for self-defense, but air combat was not its primary role. 10. Stealth and survivability. The MiG-27 was developed before stealth concepts became mainstream. Its radar cross-section is relatively large by modern standards, and no deliberate shaping or coatings were used to reduce detectability. Survivability depended on speed, low-altitude flight, terrain masking, and robust structure. Defensive aids such as radar warning receivers and countermeasures were present in later variants, but protection against advanced surface-to-air missile systems was limited. 11. Real-world service and combat use. The MiG-27 entered service with the Soviet Air Force and was later operated by several countries, most notably India, which produced and operated the type extensively. It saw combat use in regional conflicts, including operations during the Soviet-Afghan War and later in South Asian contexts. Under Indian service, operational feedback highlighted its strong firepower and speed, alongside concerns over maintenance demands and avionics limitations. 12. Cost, production and global impact. Exact flyaway cost figures are difficult to determine due to Soviet accounting practices, but the MiG-27 was intended to be cost-effective by leveraging the MiG-3 production line. Approximately 800 MiG-27 aircraft were built across all variants. The aircraft was exported to Allied states, reinforcing Soviet influence and providing client air forces with supersonic strike capability during the Cold War. 13. Strengths and weaknesses. The MiG-27 excelled in high-speed, low-level strike missions and delivered exceptional cannon firepower. Its weaknesses included limited range, high fuel consumption, and avionics that aged rapidly as precision-guided weapons became dominant. Maintenance complexity and pilot workload further constrained effectiveness in later years. 14. Final verdict. The MiG-27 Flogger represents a focused and uncompromising approach to battlefield air attack. It reflects the strategic assumptions of its era and the Soviet emphasis on speed, durability, and massed firepower, though no longer a frontline aircraft. Its legacy endures as a significant chapter in the evolution of strike aviation, respected for what it was designed to do and for doing it under some of the most demanding conditions of the Cold War.